This is physics extra credit, guys. Okay. The problem is right here, and here's a little golf ball, and we're trying to figure out what dx is afterwards. Okay. So we're going to start by finding the acceleration. We're going to use the formula A equals g times the sine of theta. And we know that g equals 9.8 meters per second and theta equals 30 degrees. Okay. So our work over here is going to be 9.8 meters per second, squared, and times sine of 30, which equals, our acceleration equals 4.9 meters per second squared. So the reason that we can use this formula is because there is no friction and the ball is rolling. Okay, so now we are going to solve for velocity final, because over here we have to find out when it hits here what the speed is, so we can find velocity initial for the parabola. Okay, we have A equals 4.9 meters per second squared. VI equals 0 meters per second. D equals 30 centimeters, which equals 0.3 meters. Now we're going to solve for VF. We're going to use the formula A equals VF squared minus VI squared over 2D. And we're going to plug it in right over here. And 4.9 meters per second squared equals VF squared minus 0 over 2 times 0.3. And we solve that out, you get VF equals 1.7 meters per second. Okay, so now we're going to solve for t. We have dy equals 0.912 meters, and the reason for that is because over here we have the height of the table is 1 meter, but then we minus 8.8 centimeters from it because that's how tall the cup is, and we're basically saying that this is the floor and then that's where our trajectory ends. So we have that, and then we have g equals 9.8 meters per second squared, and then we have t is what we're trying to solve for. We're going to use the formula d equals 1/2 gt squared. We're going to plug this in, and it's going to be negative because it's falling downwards. 2 meters equals 1/2 of, and then negative acceleration, meters per second squared, and then t squared. And then, so we plug that all in, and t equals 0.43 seconds. So now we're going to solve for dx. So we're solving for dx, and we have our velocity, which is the same as our velocity final up here, which is 1.7 meters per second. And that is the same all throughout the dx because it doesn't change horizontally. And then t equals 0.43 seconds. We're going to use the formula d equals v times t. So we're going to do 1.7 meters per second times 0.3 seconds equals 0.74 meters. And that is what our dx equals, and that is our final answer. So 0.74 meters is how far we should place the cup away from the table. And that is our dx. Oh, okay, that was good.
That was in.
Yep. Okay.